Welcome to tonight's playground. Tonight we're going to be looking at Hashicorp Consul, but also integrating it with something called smashing, which I'm a personal fan of. So we'll look into that a bit more later. Just a quick introduction about myself. So my name's Si Nichols. I'm the Head of Innovation and Continuous Improvement at ECS Digital. What we do at ECS Digital is that we help enterprise organisation achieve their global change. And the way that we do that is we help these organisations to enhance their deliveries through BDD and CI/CD and ultimately DevOps. So I see a few new faces here tonight, and that's absolutely fantastic. So thank you very much for taking the effort in coming here this evening. So just a quick introduction of what playgrounds are. So previously and typically in meetups in the past, we've all found, especially when we're talking about tech, is that it's just PowerPoint slides for a whole hour. And we find that there's nothing much to take home afterwards. You know, it's just theory after theory after theory. So we introduced this concept called playgrounds. And what we do with playgrounds is that we all spend an hour learning some new tech. It's a hands-on, so we can all go through the instructions, learn something new, and then enjoy some pizza and conversation at the end. As you can see, playgrounds are almost global, so that in the UK we're offering the events in both London and Edinburgh, and we've just recently had our latest playground in Pune earlier this month, and we did that on Jenkins. We're looking for new presenters, so if you ever have a topic that you feel that you'd like to step up here and present to the rest of the audience, give me a shout. We're always looking at new people to help us present these. So for tonight's agenda, we're just going to have a quick overview of what Hashicorp Consul is, and then we're going to go into what we believe smashing and what smashing is. We'll then have a quick discussion of the use case that we're trying to achieve in tonight's playground. We'll kick it off, have some final thoughts, and then enjoy some pizza and some conversation at the end. So before we start, how many of you are using Consul already in your day-to-day? A few, some of them. Okay, cool. So for those that don't know what Consul is, so Consul is Hashicorp's response to a distributed service architecture. Okay, so if you think about the history of applications, of where they've been and where we are now, is that they've typically started as monoliths, and as we've tried to scale up and don't touch as we try and scale up a monolith or deploy them to multiple servers, monoliths by themselves become very difficult to manage and maintain. So the typical behavior was we start to split up that monolith and we start to split them out into microservices. So if you think of the history, if you go from a monolith to multiple services distributed across your network, how do you track them? How do you work out what's running where, whether it's up, whether it's down? And so we have Consul. Hashicorp's response was, here's Consul. So what Consul offers is service discovery across your network, but also it offers health checks on those services that are registered in Consul. So what that means, that even if we say that we've got service X running over there, that's great, so we know it's running over there. Consul can also give us feedback as to whether that service is healthy or unhealthy, which is great. So that's just one of the features. In addition, if you think of that monolith scenario, where would your configuration have been stored? It probably would have been stored in a local XML file or a local configuration file attached to that monolith and then deployed to a server. Now, if we go to a microservices or architecture, we're going to have multiple configuration files, multiple XML files to configure, and that can be a pain. That can be a real pain. So as a response to that, what Consul offers is a distributed key value storage within Consul. So what does that mean? It means that if you've got your microservice distributed across your network, you don't have to store your configuration locally. You can store your key value pairs in Consul. Why would you need that? So if I'm a service and I start up and I need to work out the IP of the database that I need to connect to, instead of looking locally inside my local configuration file, I can go to Consul, find out the key value pair and consume it. Why is that useful? Well, if I've got 100 services that all need this one database IP address, I only have to configure it in one place, which is console. If I'm not utilizing the key value storage in console, I'm having to configure the same value across 100 configuration files. And you can see that can be a massive maintenance problem. In addition, what console offers is something that came out, I believe, in May of this year, is a service segmentation facility called Console Connect. So we're talking about our services, microservices architecture. We've got services all over the place. How do we control which services can communicate to each other? Okay, if they're all on the same network and you haven't got, let's say you haven't got much of a secure network, you're not really controlling the traffic that goes between these services, Console Connect can determine whether service A can communicate to service B. They just released that feature early this year, and I think it's really, really good. Final point with console as well is that we talk about monoliths and microservices, and then in our heads we probably think that microservices has to be engineered or programmed or coded in the latest programming language like Go or something. But what happens if we've got applications that have been around for 20 years that we've forgotten how to compile? How do we register that in console? And what console offers is a very rich set of APIs that regardless of the maturity of your application, you should still be able to register it inside console. Okay, so even if you've got a very old application, I don't know, running on a mainframe from 20 years ago and you want to register it in here, you can. Okay, so that's a quick overview of console. Smashing. So first question, have any of you heard of Smashing? Fantastic, good. So Smashing was something we came across a couple of years ago. So Smashing is a Sinatra-based framework. And what's really great about Smashing is it allows you to build basically beautiful and easy on the eye dashboards with the intent of displaying these dashboards on TVs around your office. Okay, and you can see an example of one here. A quick history of Smashing. So Smashing was a fork of something called Dashing, so I appreciate we can get a bit confused there. And Dashing was a framework that was implemented at Shopify so that they can display dashboards around their office for, like, you know, number of failed builds, number of deployments, and all of that sort of stuff. Dashing is no longer supported. Smashing was forked off and is regularly updated. What I really like about Smashing is inside these widgets, you can display a massive array of information. There is an open community where you can install additional widgets so that you can display data and information that's specific to your needs. So let's say that you wanted to display, I don't know, a Twitter feed, you can. There are integrations with Jenkins and other build tools so that you can display easily, you know, your build statuses and things like that. I think we had a look earlier this week and there were about, I think, over 150 widgets for you to play around with to configure your own Smashing dashboard. So that's console, that's Smashing. So what's that got to do with tonight's playground? So in tonight's use case, so this was something that we implemented with a large hotel booking company a couple of years back. So this particular company had a very mature DevOps pipeline. Okay, and what do we mean by that? Well, they already had tools for their SCM, they already had a mature build process, and they had the orchestration in place so that if you had an idea or a bug fix that needed to be, that was made in the morning, you could deploy that automatically to production probably by 1 p.m. Okay, it was very slick, it was very agile, it was very good. But when it went down, boy, did we know about it. Okay, the company was very dependent on this pipeline. It was extremely important, and it makes sense. It makes total sense because if we had let's say a P1 fix that needed to go out to production, and let's say, for example, Jenkins goes down, well, we can't deploy that change. Okay. So we have a look at the tools that would typically constitute a typical pipeline. So we've got GitHub for our source control, we've got Jenkins for our CI builds and orchestration, Artifactory for our binary storage, another one's Nexus as well, SonarQube if we wanted to do some automated testing, and obviously we need to track our changes against a ticket, and typically we use Jira for this. So Active Directory, what's that got to do with DevOps? You know, why have we got Active Directory here? Going back to our scenario, this pipeline is mature, and especially if you've got a pipeline in an enterprise organization, your authentication is more than likely going to be using LDAP and Active Directory. If that goes down, then by default your pipeline's offline as well, okay? That's why I wanted to show that there. So even though that as a CI engineer, we are on the build team, we're not supporting Active Directory, we were a consumer of that service. And when that went offline, it took out the entire pipeline. And everything was on fire. So in this scenario, let's just say of our dependent service Active Directory, if that went down and took down our entire pipeline, who do you think our end users went to? Did they go to the Active Directory team? No, they came to us. I can't build, Jenkins is down. I can't submit my code, GitHub's offline, okay? So that's one of the consequences of, it's not necessarily consequences, wrong wording, it's one of the factors to take into account when you've got a mature pipeline. There will be outages. Another popular one that we had as well was network outages. So as a company scales, it needs to rejig and refactor its network, take out an old switch, take out an old gateway and replace it, your network will go up and down like a yo-yo. But then that will impact us. So if we've got developers in the US, but our pipeline is running in UK, and they take out that transatlantic pipe, our service is running fine in the UK, I can access it, but states can't access it, so they think it's down. And what they do, they come to us and they say, it's down, what's going on, you need to fix it, I've got a P1 change, and the cycle continues, okay? So what we're gonna do in that scenario is we're going to use a very mini pipeline so consisting of Jenkins and Artifactory, and we're going to register these two applications as services inside Consul. So we're going to install Consul together, we're going to register Jenkins and Artifactory as a service, and we're going to register some health checks against Jenkins and Artifactory so that if Jenkins goes down, Consul will be aware and will be notified, okay? So we're going to achieve all of that, and to see how that operates with the service discovery and the automated health checks. Once we've completed that together, we're going to go through and stick a smashing dashboard in front of it. And what that allows us to do, that if Jenkins goes down, we can present that outage in a beautiful, nice to read dashboard that would potentially be running on a TV. Why is that important? So you could have a development team over here, a development team on the floor above us, a development team in the States. What we could do is we could isolate and display our outages in an easy to read dashboard and display it to them. So when something goes down, dashboard will automatically be updated. When it goes up, dashboard will automatically be updated. And we found this to be very effective, very effective. It doesn't prevent the outage from happening, but what it does do is it preemptively displays the outage information to say, yep, we are aware something's wrong. Give us some time, we'll get it back up. We are looking into it. We'll get it back up as soon as possible. And when we do, the dashboard will go green. But you can use it to monitor any service. So you have to have a think about what your responsibilities are within your own workplace. What do you get people coming up to you when it fails constantly? And think about that. Maybe you could start monitoring it in Consul and using Smashing to display that information. So keep calm and don't panic. So what's really important with these playgrounds is that we try and go through together and work our way through this example and hopefully get something working at the end of it. As you can see, we've got it recorded, and the code and the instructions in order to set up the environment and go through this use case will be publicly available in GitHub. So after this session, and once the video is available, we'll send you the video link and we'll send you the link for the GitHub repo so that you then can have the time to go through at your own pace, watch the video, go through the instructions. So if you're unable to keep up or follow tonight, don't worry, because you will have an opportunity to do it at a better pace by yourself. So hopefully everyone has filled in the survey and has logged into the SSH session. A quick thumbs up if we're good. Yes, 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 yes. Cool, fantastic. Cool, thank you very much for that. And let's kick off. So the first thing we're going to do is we're just, in our environment, is we're just going to double check, do a quick manual eyeball that Jenkins and Artifactory are up and running. So inside the browser, copy your URL, open a new tab, and just go to port 8080. Cool, my Jenkins is running. And in another tab, go to port 8081. And fingers crossed, Artifactory should be available as well. And this is really important first step. Who hasn't got a working Artifactory or Jenkins? All good in the hood. Cool. So what we need to do first is we are going to install console. In order to do that, we just need to do a quick setup on environment. If we have a quick look, we've only got our GitHub repo located. What we need to do is we need to create a bin directory, which we're going to place console, the console binary into. By creating this bin directory and moving console into this directory, it means that we can run the console command regardless of where we are in our terminal session. Okay. Next step is we want to download console. So there's many ways to do this. The quick one is to go to console.io/downloads.html. I just wanted to show you that if you wanted to install console on your own environment, this is where you need to go to. For this particular environment, we're using, so all of these servers are in Amazon, and we're using the Amazon Linux AMI. So because of that, we need to make sure that you copy the link for Linux 64-bit. Very, very important. If you download any of the others, they're not going to work. So I'm going to right-click on 64-bit and copy link location. Very important. Don't accidentally do, I don't know what somebody did a Debian one or something the other day, it didn't work. So 64-bit, right-click, copy link location. Back to our session, so obviously we want to now download this. That's all right? Are you okay? That's all right? We'll do this together. So console.io/downloads.html, Linux 64-bit, right-click, copy link location. Okie dokie, and very straightforward. We just want to do a wget and paste your link. So you can see that the latest version we've got at the moment is 1.3.0. And why it was important for us to get the latest link is that the instructions currently in GitHub is 1.2.3, 1.2.3. 1.3.0 came out early, I think, or this month, so I wanted to make sure we got the latest one. So if we do a quick ls, we can now see we've got a zip, and we just need to extract it and place the contents in the bin directory. So in order to achieve that, I'm just going to do an unzip, space, name of the zip file that was downloaded, space, -d, which says which directory do we want to put it in, and stick it in a bin directory. Here we go. And to prove that worked, I can just type console, and the command should work. That's why it's very important to put it in the bin directory for this instance, because it means it doesn't matter where I am. So the tilde at the bottom there indicates for the home directory for the playground user, but if I'm root, if I'm in the temp folder, console command will work regardless of where we are. So that's why that step's really important. Okay. So we want to now start the console agent, but before we do that, there are just two folders that we need to create. One of them is a configuration, a config directory for console, and another one is a data folder for console. The configuration folder just contains the config, obviously, for console, and the data will contain the state for console, and that's why we need those two folders. So very simple in a Linux environment, we can just call the folders whatever you want. I'm just going to call the first one config, so make the config, and secondly, make the data. Just keep it simple. So now if I do an ls, let's try an ls out, you can see that I've got config folder, data folder. Not sure what. Somebody on this box. Somebody is on this box. I will move box. As you can see, somebody has created a config folder, so we seem to be clashing, which is fine. I will move to a different box. So whilst I just quickly set this up, even the Terraform scripts that will create this environment are available. So if you run the Terraform code, it will set up Jenkins, Artifactory, all of this bits and pieces. So what's that for? Yes. Strip it down and start again. Okie dokie. Just give me 2 seconds to re-download console. Okay, so for those that are trying to catch up, wget, make the bin, unzip into the bin folder, -d bin. Okay, looking good. And then I just need to create my two directories, config and data. All good in the hood. Okay. So now that we've completed that, well, quick check that console command works. Yes, it does. So what we want to do now is we want to start console. It's very straightforward. So first part is console space agent. Okay, don't hit enter once you've done that. There's a bit of a command that we need to build up here. So there's a couple of flags that we need to go through. So the first flag we're going to specify is dev. So console is engineered to work in a cluster. Okay, it's very important. That's the main DNA for console, is to run as a cluster. When you start console in production mode, the cluster will start to talk to each other. It needs to establish who's in charge, who should I send messages to, what logs am I missing, all of that stuff. So it's very important that that cluster is established. By specifying the dev flag for this workshop session, it runs the agent in dev mode, which means don't bother to try and speak to a cluster, okay? Just work in isolation. So when you're playing around with console and you're trying to just work out how it works, use the -dev flag. But if you are then trying to POC console in your workspace, or you're even trying to then get console to run in production on a production environment, do not use this flag. It's highly not recommended to specify that. So I wanted to make sure that you all knew what that meant. So the next flag we need to do is we just need to bind is -client, so that we bind the running of this console to the port. Straightforward. If you remembered earlier, we created a config and a data directory. So let's now specify them as arguments. And the first one is -config dir, and then just specify the location of your config directory. I'm just going to use an absolute path here just to be on the safe side. So what this means, obviously, is that when the agent is running, it knows to look in this location for its configuration. And then process of elimination. The next one we need to do is data, and then again. data. Cool. So it's entirely up to you. If you wanted to, I'm going to use one session, so I want to run this process in the background and not terminate. So in order to do that, I want to specify ampersand. And so also I want to specify no hop. So as a shortcut, if you're not sure, if you press Control A, it will take me to the beginning of the command. Control A. And I just want to specify no hop. If you're not sure what this means, so the ampersand means send it into the background. No hop means that don't terminate if you receive a hang up signal. Typically when you receive a hang up signal is when you log out of your session. It will then kill the process, whether it's running in the background or not. So that's why we want those two, just send it in the background. Okay, so this is the UI. There was a conversation earlier about data centers. So if you have a look in the top left-hand corner, you can see it's DC1. So the conversation came up as how to establish or how to work out clusters based on your network. And one of the things that Hashicorp recommends is that you have a cluster per data center. Okay, and you can see at the top here, that's where we've got, that's what DC1 means, represents data center 1. Okay, so let's have a quick tidy up. Okay, so if we have a quick look of what we were trying to achieve before, obviously, the network problems, we checked that Jenkins and Artifactory were running. We've just installed Consul, so we did wget, downloaded it, extracted it, etc. So now what we need to do is we need to register the Jenkins service and the Artifactory service inside Consul. And the way that we can do that is we can specify service definition files inside Consul. So let's quickly open up a new tab. Okay, so in the home directory, we've automatically downloaded, if you have a look here, we've automatically downloaded the repo from GitHub, which I'll send you to a link to after this event. So if we go into that folder and have a quick look, there is a folder called Console. So if we go into Console, and then we've got a folder called Services. And this is where our definition file templates are located. And as you can see, once we've run that, we've got two JSON files. So service definition files in Console are using JSON, and we've got one for Artifactory and one for Jenkins. So we just need to make a quick tweak to these two files and then load them into Console. So let's start with Jenkins. So I'm going to use Nano. And it's pretty straightforward when you have to define a service inside Console using a definition file. You could use the API, for example, but if you wanted to specify the service in a JSON file, you only actually need the top 3 attributes, the name tag, well, not necessarily tags either, in the port. And what we've got here is that we've also then got the check. So remember with what we said with Console earlier, that it was about service discovery. So the top bit is the discovery, the second bit is the health check. What do we want to probe? What do we want to constantly ping or check that will give us an up or down for this particular service? So all we're going to do is for the HTTP attribute is we're going to specify the port that Jenkins is running on. And I just type HTTP localhost port 8080, because remember we did the check earlier. And that's it. That's all you have to do to specify the definition for a service and determine what the health check will be. Very straightforward. And you can see the value at the bottom for the interval. How often are we going to check this URL? And we've just specified 15 seconds there. So I'm just going to save those changes. What I now need to do is I need to, first off, transfer them into the configuration directory, and secondly, reload Console so it picks up this new change. So I'm just going to copy it. So let's copy Jenkins. and let's transfer it to the config directory that I created earlier. Okay, pretty straightforward. I need to now tell console, hey, there's a new file, there's some new configuration for you to pick up. So let's let console know. In order to do that, I'm just going to do a console reload. And we get a nice message to say that the reload has been triggered. For visual confirmation, I can go to the UI. If I give it a quick refresh, I can now see, let me just zoom in for you. I can now see Jenkins registered. Okay. So just to build upon the service definition, not the service definition, the service directory is the discovery. So what this now means is that if you've got console established within your organization and somebody wanted to know where Jenkins was installed, for example, all they have to do is come in and send a query to console to say, where's Jenkins? Console will return the IP. And then we can quickly bury down. If we click on it, we can see that it's healthy. And then if we click on it again, we can see the checks that are being executed specifically for that Jenkins check. And there's the message that's being returned if you're interested. So you can see it's just doing a get, and we're getting a 200 HTTP response there. All right. So let's repeat that process for Artifactory. Bit big there. So I'm just going to again modify the Artifactory, and you can see I've just got to specify the URL for the Artifactory service. Cool. So let's quickly do that. Let's save it. Let's exit. And let's copy that again back into the configuration directory. And if you remember, we just need to reload console, so let's execute that command. And if we quickly go to console and refresh, so this was important. I wanted to quickly show this. If I go to the main services, so you can see that it's actually saying the health check for Artifactory. It came up as red. And the reason for that, that's default behavior with console. Whenever you register a new service, it will assume it's down until it's run the first health check. Okay, so don't be alarmed that if you've registered a service that immediately says it's failed. It's because it hasn't executed that first 15-second cycle to then get a positive or a healthy check on that service. So just be aware of that. So if we look at what we've done now, we have double-checked Jenkins and Artifactory is installed. We've installed console, got it running, and we've registered 2 services. So let's just quickly test that the health checks are working. So I'm just going to execute, I'm just going to take Jenkins offline. If I go to the URL for Jenkins, you can see it's offline, so that's great. And then obviously if we check the console UI, we can see that something's not right with it. Now, again, going back to why we started using console for monitoring of our DevOps pipeline, this from an engineer's perspective, it's very good. So if I'm the person that's responsible for keeping Jenkins healthy, or Bamboo, or Stash, or Bitbucket, or whatever, as an engineer, this is good because I can visually see it. I can start clicking on it. It's like, why is it giving me something unhealthy? Great. The port 8080 health check's failing. I can click in and I can see the output from it. So as a person that is responsible for keeping this service alive, the console UI is good. It does exactly what it does for me to do my job. One of the things you notice is that it doesn't auto-refresh. The UI doesn't auto-refresh. Okay, so when Jenkins went offline, I had to manually refresh it in order for that to be reflected here. So then again, if I've got consumers of my DevOps pipeline, it's probably not a good idea to show this. We've got all of these bits and pieces up here. They don't care about that. They just want to know whether my build service is up or down. Can I check in code? Yes or no? And you can see, obviously, because of the auto refresh, it doesn't help. And then, there's just information that's not relevant to them. Okay. So this is where smashing comes in. So what we're now going to do. So we've just completed this section here, Okay, what we're now going to do is we're going to add smashing to the top so that when there is an outage, it's just displayed nice. It's displayed a lot better. It auto refreshes, auto updates, and it looks good. Yes.
So you kind of register the services and then you restart or reload it the console.
So I had to define it first. So I had to modify the JSON file for my service. Then I had to copy it into the configuration directory. Then I had to tell console to pick up the latest config, because console is running. But what console doesn't do regularly is constantly check the config dir. So what we don't want to do is we don't want to take console offline totally, so we could have killed it and then started it again. What we just wanted to say to console is, hey, we've updated some configuration, can you pick it up, please?
Is there an alternative way, like a service?
Yes, so the way that we've defined a service is that we did it through the JSON, but as on the console side, it has an API on it, so you can send it a command that will just load in the service. So for example, if you started a new service running on this and you don't want to specify the JSON, you can send it an API call and specify your JSON as part of that load into that API call. So yes, that is possible. Exactly, yeah, so what console would do is then write it locally. So I think that's a great question there. So there's multiple ways that you can register services in console. So the way that we did it, because this is all running locally, is that we defined the JSON file and we loaded it into console ourselves. But then if we've got a service that's running somewhere else, but we wanted to register that service into the nearest console, we can send it an API call. So yes, that's possible. Okay. So let's get smashing up and running. So I'm currently inside my GitHub repo, console services. So I'm just going to go up 2 spaces. And if I have a look underneath here, I've got a folder called smashing. So I'm going to navigate into that. So this code is all available from the public smashing GitHub repo. Okay, so if you do like a git clone, this is what you get. What we just need to do, so I just wanted to show how easy it was to get smashing up and running. So I just quickly need to switch to the root user and then run a bundle install. Again, environmental. Bundle's not recognized as the current user, we get permission issues, and then if we run it sudo, it doesn't work. Cool. So I just wanted to show you how easy it was to get this working. So if you wanted to install smashing yourself, all you've got to do is clone the smashing repo, gem install smashing, and then do the bundle install. It's really, really straightforward. Okay. One thing to bear in mind that we came across, it's an open bug that's known with smashing. When you typically run the dashboard, you would run something like smashing start. This is a problem when you're running on Amazon machines. When you run smash and start, it uses the thin web server, and it causes problems when it's trying to communicate with a cloud server. Okay, so there's I'll find the issue later, but it's a known problem if you use this command. Why I'm bringing this to your attention is that if you're trying to run smashing in your own environment and you're running it against an Amazon machine, documentation will say you need to use this command. It will run, but the dashboard won't update. Okay, just be careful. It took me half an afternoon to work this one out. So the workaround is to use the Puma Webserver. Okay, and the command to run it, again, it's documented as well. It's just Puma, name of the configuration file. I want to run it in the background and not terminate. So documentation will say smashing start. If you're running it on an Amazon machine, the dashboard will not automatically update. Workaround Puma config. Okay, and it will use a different web server. So let's check that this is working. And so for this port, the default port for Puma is 9292. And if I do /sample, awesome. So I can see it says my super sweet dashboards. There we go. I've got to be honest, I really like Dashim. So this, when you do a git clone of smashing and pull it down, this is just some dummy data and stuff, but you can see how I don't know, just how it displays data and information easily. And if you imagine you've got flat screens around your office and have a dashboard like this automatically updating, it looks good. It looks really, really good. At the bottom, you can, if I scroll down a bit, it will provide a sample curl command that will allow us to update this widget here. So if we say it says your shiny new dashboard, and then we can update the message. So I'm just going to quickly show you how easy it is to send new data to Smashing Dashboard. So I'm simply just going to copy the command that they've provided. Going to paste that in. One of the arguments for the payload is an authentication token, which is configured in config.ru. So I've specified it as Playground. But I quite like this feature, this security feature, because obviously if you've got a dashing Smashboard running that you're in charge of, you want to control who can send updates to it. Therefore, you can use the auth token. And then we can say, hey, look what I can do. So let's send that out. And then you can see that the widget updated. So I just wanted to show from the sample dashboard using the curl command how quickly and easy it was to push updates. So if you think about, again, utilization of smashing in your day-to-day, it's very, very easy to push updates, very easy to push updates to it. So at the top, I'm using the sample dashboard that comes out by default. What we're going to do now is we're going to use a pre-configured dashboard for our DevOps pipeline. So change dash sample to dash playground. And this is what we used at the company. So what we did is we had a widget for each product, each application in our DevOps pipeline. So you can see that we had something for our, I think we were using Bamboo, we were using Stash, which Atlassian renamed to Bitbucket. We had Jira, I think we had Artifactory, Confluence, Miscellaneous. Miscellaneous was very important. So what we displayed in Miscellaneous was any third-party service that we were dependent upon. If Active Directory went down, if the network went down, I'm not solely responsible for them, but I was watching them. And if they went down, I updated Miscellaneous. So if somebody came up to me and says, I can't log into Bamboo, it's like, well, yeah, Miscellaneous is saying AD is offline. So, and this is what we're going to update. Now, if we go back to what we were trying to achieve, so we've done all of this, we've done this bit, we've installed our Smashing dashboard. Now all we've got to do is link console so that when an outage occurs in console, it will send an update to Smashing, okay? And a way that we do that is something called a watch in console. And let me just quickly show you what a watch is. So again, as with our service definition, we already have some watch definition files configured. So let's have a quick nose at one of them. So what a watch does inside console is it monitors for state change in console. So you could change a key value, a status health check could change from healthy to unhealthy. It's not specifically for a service, it's anything in console that can go through a change. You can create something called a watch that will monitor that change, okay? And then when that change occurs, it will kick off a handler, okay? So what we're doing here is we're going to tell this Jenkins watch to monitor the Jenkins service, and when that changes, kick off this shell script. That shell script will then update Smashing, okay? But it's not restricted. What's really important and with watches is that they're really powerful. So if you're using console for your key value storage, for example, and with our example earlier, we were using the database IP, you can configure a watch on that database key so that if somebody comes and changes it, it will fire off a watch. And that's what's really important. So if somebody is changing it and they shouldn't do, or they're changing it to a value that they shouldn't do, a watch can monitor that and kick off the corresponding handler. Okay. So all I just need to do in this is I need to specify the name of the service I want the watch to be associated with. So I'm just going to put Jenkins. Save that. Let's just double check that that's saved. Perfect. And I'm just going to repeat that process for the Artifactory. And as you can see here, this is the definition. I just need to specify the service name for Artifactory. Save and exit. So now that I've configured these two JSON files, what do we need to do next? What did we do with the two service definition files? Reload was one of them, and then we had to do something before we did the reload. Well done, sir. Absolutely. Yep. Gentleman's absolutely right. I need to move these to the config directory. So let's quickly do that. Let's cheat and do them all at once. And do a console reload. Cool, all done. Interestingly, with watches, there's nothing really visible to indicate that that watch is working, if that makes sense. There's nothing in the UI yet that will allow us to indicate that, hey, this watch is triggering. So what we're going to do now is we're just going to shut down Jenkins, see it go down in console, and then cross our fingers. So I'm going to replicate an outage of Jenkins, so I'm going to take it down. Was it not already running? Use that. So let's just double check that that is up. Cool. Just wanted to double check. So, you saw it flash. So let's quickly go through that again. So I'm going to indicate an outage. Let's say that we run out of space or we run out of storage or something with Jenkins and it terminated. So let's replicate that. Jenkins has gone down. If we quickly refresh this. So again, we want that health check to kick off. I think we had a 15-second interval for that. So let's just quickly. So now console has registered the outage. Thumbs up. And then if we check our dashboard, and I really like this. So if you imagine this on a flat screen on the side there, which is next to the development team, all they need to see now is that Jenkins is failing, which means that their builds aren't going to work. Okay, that's all they need to know. It is acknowledged that the build service is offline. I mean, you can move this stuff around as well. It's all, you can do whatever you want with it. So following on from that, let's quickly take Artifactory offline. Okay, so I'm taking Artifactory offline. And then if I go straight to the so again, we want to wait for that watch. There we go. I really like that. I really, really like that. But this was obviously specific to the services that we were in charge of with regards to the mature pipeline. You have to have a look into your own day-to-day. What services are you in charge of? What goes offline, etc. What are you getting requested when you're in charge of something, it goes down? What are they coming up to you to fix, to ask you to bring up line very quickly? So let's just quickly bring Jenkins back online. And then if we check our dashboard, we just need to wait again for that health check and for the watch to kick off. So remember there was that 15 seconds. There we go. And I like it. I think it's, what I like about this personally is its simplicity, but its effectiveness as well. It's very straightforward, and it was very useful for this particular company is that we had globally distributed development teams. So we could just send this URL to a team in the States, and they can say, here's a live status of the pipeline that you're using, okay? When it goes yellow, we know it's gone down and we're looking into it, but it's just that quick Okay, something's wrong. Fantastic. So, at least I've completed the playground tonight. Apologies for the network problems that we experienced earlier. So what I wanted to, if you wanted to take this further, these are a few recommendations that I provided. This is what we did again when we had to use it at this company. We integrated with Jira, so that was the first thing, so that whenever we experienced an outage and the dashboard updated, it automatically raised a Jira issue. Why that was useful is that we displayed the Jira ticket number inside the dashboard, so that when people saw that a service outage had taken place, they saw the Jira ticket and they can go and watch it. Then we could add a comment to say, like, DB is offline, acknowledge DBAs are saying that it's a 60-minute turnaround. And if the people that are consuming your DevOps pipeline are watching this Jira ticket, every time you get a comment update, they automatically receive the update as well. So it was very effective. The second thing that we integrated with is that we pushed our outage status to something called Graphite, so that we could start tracking historical trends of outages. And what that allowed us to do, especially with networks, is that we started to see patterns that it was occurring at either specific times, specific days. And Graphite allowed us to provide that historical trends so that we could start having some data for proper root cause analysis. So at the beginning, it was happening probably 4 times a month. When we realized that things were being updated and network was being taken offline, we start to report on that and reduce those outages based on network problems, etc. Another one that we did was that we integrated automatic notifications to the appropriate parties when a service was offline. Okay, so again, it's just another thing that you can do if you want to. And then because we used the -dev flag, and as explained earlier, you'd want to get console running in a cluster. That's really, really important. If you are running console agent on anything but your laptop and you are using the -dev flag, that's a no-no, okay? Just definitely set up console as a cluster, okay? So just a quick plug. So ECS Digital are official training partners for Hashicorp, okay? We deliver training for Hashicorp in the UK, and we're starting to deliver training for Hashicorp products in Singapore as well, covering Terraform, Vault, and Console. Our next training session is at the end of November, 26th to 29th of November. So even if you go to hashicorp.com/training, you'll see us. We are their official certified trainers. So if you're using any of the Hashicorp products, or you've got knowledge gaps, or you want to expand, or you want some better understanding of whether you're utilizing the products properly within your organization, certainly consider joining us on this training session. So you can book it through the URLs there. Our next playground is going to be scheduled for January, and we're planning to do Jenkins. Thank you very much. I'm really sorry about the network problem that we had. I'll make sure that we don't trip over that next time. Keep an eye out on our meetup for the DevOps Playground Singapore. I hope you've enjoyed tonight's session. I hope you've gotten something from it and benefited from what we went through today. Otherwise, I'll see you all at the next playground. Cool. Thank you very much.